Hey everybody, it's Larry with Leading Edge, and we're going to go over a couple of things to start off when you get your machine. These are some questions and concerns that we've had from other purchasers of our machine, so we thought we'd throw a video together for you. As you see here on our cart, the machine's been removed from the pallet. It's sitting on our tool cart, our Waterloo tool cart, and we're going to go through the very first steps you're going to need to do to get your machine going. So the first thing I'm going to do is I'm going to reach in the back here and I'm going to turn the machine on. Just so we've got working lights. We've got a nice LED light system in there, and sometimes it helps to do what we're about to. So if you notice, the very first thing when we set it up, the gap in the doors is uneven. From top to bottom, it's a bigger gap at the top than at the bottom. And this is traditionally the case that you're gonna find. Very rarely will you see them the opposite way. But if you do, that's not a big deal. We ship them this way intentionally. And the reason why is because we throw a shipping strap over top of this, which pulls everything in. And if it pulls in too tight, it'll rub against the powder coat here. So what we do is we put a cardboard tube in here. You should have received the cardboard tube. You want to pull that tube out. And then you'll notice that the sides flex a little bit. This is intentional. This is not a design defect. This is intentional. And what you want to do is you'll come in and you'll grab both sides and you're going to slightly push the doors together. And what you're looking for is a nice uniform gap from top to bottom. That gap there is about 1/16 of an inch, and that's fine. So in order to tighten that up, you're going to use just about every screwdriver set anymore comes with these T15 star pattern bits. So you're going to take the star pattern bit, the T15 bit, and you're going to, once you align the door, you're going to carefully open the door so it doesn't come out of alignment again. And these screws, these two screws here, they're snug by the factory, but they're not tight. All you have to do is put your star pattern in there and give it about a 1/2 to 3/4 turn. And you'll do that to both sides. And that gap should still be the same. That's a little bit tighter, isn't it? So what happens when you turn these screws, sometimes it'll pull just a little bit. So we're gonna give it a tap out, make sure it's not too, the gap still looks pretty good. When we tighten it up, it should tighten that gap. And that's what we're gonna do right now. There you go. Now the gap should be more uniform top to bottom. So now that you got the door, now that adjustment will have to be made anytime you move the machine. There isn't a full surround on the front here like there is in the back. So anytime you move the machine off of the cart to say a table, or in many cases our customers are now using these as recruiting devices. So they're loading them in the backs of trucks and cars and taking them to other schools, high schools and stuff like that to help pitch the kids to get them interested in the trades. Anytime you do that, you're causing flex to the machine and it would cause the doors to maybe come out of alignment. Just bring your star pattern and do that. And it takes all of 10 seconds to do. So, or 30 seconds. So from here, we're gonna go ahead and open this up. So we've got full access to everything inside the mill. Open up the doors because we don't need to turn on the spindle or anything. If you notice when we open up the doors, on the inside of the door, there's two white boxes. Those white boxes are permanently glued to the door. And what they are is that's the sensor that reads, it's a door sensor that turns the spindle off if the door is open. So if you are trying to get your machine to run and the spindle's not working, it's more than likely the culprit is the door switch is not, or the doors aren't closed so the spindle won't operate. We do this so you can't accidentally stick your hand in there. So now we've got the machine open here and we're gonna cover doing gib adjustments. So gibs, on our machines, we have a 55-degree dovetail gib system. And the gib system is, if you did two dovetails that were just perfectly matched, eventually when they're sliding over top of each other, they'll wear. One side will wear unevenly than the other. And if there's no adjustment there, then after it wears, you can't use the machine anymore. So what we have is we have a gib that goes in the middle, and it's made of a softer steel material that will rub away before the other materials on the dovetail rub away. And what it is you have the gib with adjustment screws, and the adjustment screws apply pressure to the gib so it rides on one of the dovetails. And eventually, well, not eventually, when you first get the machine, the dovetail needs to wear in. So we run them here for between 4 and 6 hour break-in program, but that's still not long enough to fully wear in the dovetail. It takes about 60 hours of constant operation before the dovetails run in. So there's a couple things we're gonna cover here that will accelerate that. And they're not just recommended, they're mandatory maintenance procedures that you're gonna have to do on these machines. This is not unique to our machines. Anybody who's ever used a Bridgeport style knee mill or a Tormach style mill or even some of the more expensive CNC mills has had to do a gib adjustment on them. It's very simple. It takes a little bit of practice with our machines, but once you get it down, you'll be able to do it in no time. And after a while, you'll only have to check it like every 20 hours. So let's go ahead and we're gonna cover those areas right now. In order to see the X-axis gib adjustment, we're going to use our T15 star pattern screwdriver again, and we're going to remove this motor cover here. This is our stepper motor cover. This thin sheet metal here is our stepper motor cover. We're going to remove that, and we're just going to set it over here in the corner off to the side along with our screws. Many times I like to put the screws back in place so I don't lose them, and just give them 2 or 3 threads on there. Being careful not to cross thread them. And that's just to hold them in place. What you'll notice is we can see on the front, on the X-axis, this is where our gib adjustment is. We can only see 2 of our gibs here. We're gonna jog the axis over so that you can see all 4 of the gib adjustment screws. Right now, we're gonna show the 4 gib adjustment screws on the X-axis and the 4 for the Z-axis and how to check those. The Y-axis is a little bit harder to see, so what we'll do is we're gonna go out and we're gonna do a very simplified view of the Y-axis, but it's done exactly the same as the X and Y, or the X and Z. So in order to do that, let me fire up our computer here. Didn't like that. It was already connected, that's why. And we're gonna jog it off of the table. One thing to remember when jogging is many people like to look at the table and say, I wanna move the table this way or that way, you know, left or right, and that's how they use the arrow keys. Well, if you do that, it's exactly the opposite. And the truth is, the way that you're supposed to move the machines with the arrow keys is everything works off of the spindle. The spindle is what you're cutting with. So you're driving the spindle. If I want the spindle to move forward on the table, then I move the forward arrow, or the arrow that's closest to me. If I want it to move to the positive side of the X, then I move that arrow. Everything is from the head and not from the table. So start training yourself now that you're not moving the table. The table's the one that's moving, but the head is what you're driving. This is what you're cutting. This is the focal point of the entire machine, is this head here. So get in the habit of doing that now. That way you're not losing bad, or using bad habits. So now that we've got this here, I'm gonna move the axis up a little bit farther so we have room to use our 3mm hex wrench. And typically what I do on this one here is I've pre-loosened up the nuts here. And these are our gib screws. But typically what I'll do is I'll adjust the first inside screws and then I'll adjust the outside screws. And the easiest way to do that is to just stick your 3mm tool in there, give it a twist until it locks. And if you watch my fingers here, I'm only using about 2 fingers of pressure. And I'm just getting it to where it locks, and then I want to break it loose. And that breaking loose is maybe a 1/12 of a turn. It's a really tiny turn backwards. And you can do the same thing with the other inside screw. And you're just gonna break that loose just a little bit. And we'll do that for all 4 screws, but start with the middle and work your way out. Now, once that's done, then we're going to go back to our control panel and we're going to jog left or right and make sure we didn't adjust that too tight. I'll show you what that sounds like here in just a second. But what you want to do once you adjust it is you want to slide it through its entire extent of movement and make sure it doesn't bind. Now this demo machine's been well worn and well used and broken in here, so it's going to take a bit more pressure to do this, but it's good because it's going to be more of an extreme exaggeration of what you're doing. But let's just say I'm going to take these two middle ones here and I'm going to use the higher torque end and I'm just going to squeeze that, maybe give it another half rotation. Now when I try to move it, it's probably going to make a loud noise. That means you've made that gib screw too tight. One of the gib screws is too tight. So when you're first learning it, this is the hardest thing to learn. It's the hardest thing to grasp is how tight can I make that? Well, you want it so tight that there's no side to side movement on the table. You don't want that table rocking side to side. You want it to be nice and level and smooth. If it's rocking side to side, it affects tool wear, machinability, you can break tools that way, and really you're not holding any kind of tolerance if there's any movement on there. You just want it to be nice and snug so it can ride forward and backwards. So you want that a nice solid friction fit on there. So I'm going to go ahead, I'm going to loosen this one back up here. I'm going to go back to my lower torque on my longer arm here, and I'm just going to bring it over again using 2 fingers and break it loose. And once I do that, I should be able to move it left and right, or positive and negative in the x-axis. And once we're done with that, we're just going to go ahead and snug up our nuts here so they don't back off. After a while, you don't even need these in place. For the most part, the x-axis and the z-axis, you don't even need them in place because they won't back out. As they start wearing in, they just won't back out. But this is an adjustment for the first 6 months. We tell everybody the first 6 months, this is the adjustment you'll make on a daily basis. And one of the things we tell you when you first get the machines, or we recommend when you get the machines, is break them in every single day. There's a break-in program that you get on the little thumb key or the downloadable from the website. And it takes anywhere from about 20 to 40 minutes depending on which one you're going to run. But we recommend running them every single day. And the reason why we recommend that is because it covers the entire extent of each axis. So it'll move each axis from the most positive to the most negative range of motion on it. And the nice part about that is it breaks in the dovetail all along the way. The reason why we recommend doing this is because as you're running projects in school, if we just left you to do it while you're running projects, almost everybody runs the project dead center of the table because it's easiest recognizable. We love symmetry, so we're going to put it dead center of the table. And we're going to do it dead center, you know, both left and right in the x-axis and dead center in the y-axis. Now, most tools you're going to be using are going to be shorter, stubby length. So now you're only using the lower portion of that z-axis. Now later on, when you need to use the upper portion, you're going to start binding up here. So one way to alleviate that is to every day come in, lubricate the ways or the gibs. You're going to use your oil to lubricate, and we'll show that here in a second. And then you're going to use lithium grease on the screw, and you're going to run the break-in program, the 20-minute or the 40-minute break-in program, at least a minimum 20-minute for the first 6 months. Run this every single day, and it runs the spindle in, it runs everything in there. It's the way to make sure your machine runs flawlessly for the rest of its life. Once you've done that, whenever you fire it up, if it's 2 months, fire it up in 2 months, and it should work just fine. We're going to run through all of that here, but it's very important that you run those. Now the next axis to run in that's the easiest to get to, I'm going to step off to the side here, is the z-axis. Once again, you'll see that these ones are a little bit shorter. We don't have screws on those. We don't have grub screws or nuts on those to hold them in place. These ones are set far enough in that they hold into place pretty much on their own. And many times what we'll do just to make sure that they do that offhand is we'll apply a light coat of anti-seize on there, and it'll run right in and won't back out. So right now what we're going to do is we're going to do the same thing. We're going to tighten up the middle and we're going to back it off. Tighten up the middle and we'll back it off. Same thing with the top. There we go. And now, once again, we want to move it up and down. And what we're adjusting here, you can see it on the x-axis. If you look over here on the side, on the x-axis. So you've got your, the y-axis. You've got a gib here in the middle. You've got your dovetail for the base right here. And then you've got your dovetail for the saddle that rides on that base. The wearing portion of it is this part right here, that's the gib. And all we're doing is we're applying more friction to that gib so that this wears and not these parts here, the mechanical parts that you want. Okay, so this is how we adjust the y-axis. It's easier to show on a stripped down version of our machine. So we basically just have the base and we have the saddle here. We removed the x-axis slide here, but this is typically where the x-axis, not typically, it's where your x-axis goes. There's no other place for it. So there's two adjustment screws. This one's different than the Z or the x-axis in that it only has two gib adjustment screws on it. There's a third one in here, but that was originally used for locking the axis down. We don't use that. We just use the two on the sides. And all we're going to do is, once again, we're going to take that, we're going to give it just enough pressure to get it to engage, and then we're going to back off. Just enough pressure to engage and then back off. And right now I've made it just so that I can move it with my hands. But what you're after is when you do the adjustment, you don't want any side to side movement on this. If that's rocking, you can't have that movement. Otherwise, your machine's out of adjustment. Now, I have to have just a little bit of movement here so that I can move it back and forth by hand, but it's very close to being fully, well, that would be fully adjusted there. And now you have no rocking side to side motion. So that's number one way that you can tell whether or not you've got the gibs adjusted. If you can take it and you can shuttle the sides, the axis side to side, or give it a little bit of a shimmy, that's too loose and you want to tighten that up, you want to snug it up. As they wear in, you'd be amazed at how much pressure you can actually adjust these gib screws with without it binding. However, in order to get there, you have to run the daily break-in program. You have to do your daily maintenance. You have to do your daily oiling. Otherwise, you'll never get there. You'll constantly be fighting the gib adjustment screws every time you use it. So make sure the first 6 months your operations are very much clockwork on this. Okay, so now we're going to cover lubrication of the machines. Lubrication is really easy, and it's done with two materials. We've got a spray lithium grease here that we use to coat our screws, and we've got along with your introductory kit, you should have received an oil applicator. Apply that with whatever oil's recommended in the manual. It's changed 2 or 3 times since when I first did this. So I'm gonna say use the manual to buy the oil that you need. Everything's over the counter and you can pick up all of this at the local hardware. So what we'll do here firstly is we're gonna come in here and we're just gonna give a nice liberal amount of lithium grease on the screw. And we do this when we first start running the machine. You're gonna do that for the y-axis, the x-axis, which is underneath. That one's a little bit more difficult to get to, and you may have to bend the straw, and that's usually how I do it, is just bend the straw and make sure you don't pull it out like I just did. But bend the straw and you can aim it. And you just want to give it a nice squirt. You will get grease and oil on the bed here. Just wipe it off. You have a rag and wipe it off here as you go. Having grease and oil mixed together isn't going to hurt anything. But you're going to do that for all 3 screws, the x-axis, the y-axis, and the z-axis. So we've got the y-axis, the x-axis, and then the z-axis. You're going to pull back the cover here, and you're going to spray the screw, and then you'll jog the axis down, the head down, and you'll just spray the screw at the top. And you want to make sure you give it a nice liberal coating on there. You don't have to soak it, but just give it a nice liberal amount of oil or grease. Then using your oil applicator, you're going to just put a little bit of oil on the flat here. And then you're going to do it on the dovetail on the x-axis. And the x-axis, once again, is probably the hardest one to get to. but after a while you'll get it down, and you'll do it on the front and the back, and you're just putting it on the dovetail. That's all we're doing. What I like to do also is give it a little bit of squirt here at the corner of where the gib is, and that'll help bring that in. And you can do it on the other side as well if that. And then we're going to do the same thing over here on the Z-axis. I'm going to apply it along the dovetail. With the Z-axis, I like to do it just from the top before you run the machine. So jog the head down, do it just from the top and let it run down slowly. As you can see, it runs down slowly there. And then you can start running the break-in program, and the break-in program will evenly apply the oil along the axis. So now that we've got that well lubricated, we can go ahead and put our X-axis cover on, and we can get to running the break-in program. Okay, so now we're to the point of running the break-in program. We've done all of our adjustments, we've lubricated all the axis, and now what we want to do is we want to run our break-in program. Now with your machine, you received either a USB or you received a link to go and download the latest break-in program. And I would highly recommend you visiting our website and product page to make sure that any new updates you're getting and you're running those. So what we're going to do is we're going to go ahead and fire up using our lead controller. This is the new software that's going to be released ideally in the next week. And that's why we're showing it in this video. So we're going to go ahead and we're going to fire up our lead controller. We're going to go over to tools and we're going to tell it to connect. What it has to have is it has to find a COM port to connect. So it'll come over here and it'll list any COM ports that are available. And ours happens to be COM26, so we're going to select that. And the very first thing you're going to notice is it asks you or tells you that you have to run a cold start routine. This is so that the machine knows where home is. If you were to just start running the machine from here, there's no repeatability for it. So wherever you set down the machine last time is where it starts. By running a cold start routine, we move our machine to the most positive axis extents of each axis, and that's home. And then from there, we can move and we can set a fixture, we can set our workpiece or whatever, and it's completely repositionable. We can, as long as we move from home to that position, we know always where we are. So we're gonna click OK because there's no other option. And you'll see the machine will move first in the Z axis so that it clears the entire axis, or it clears the workpiece or fixture or whatever you have in place. And then it moves X and Y together, and those two will home together. So now that we're homed, you'll see on the screen that we have our X axis, our Y axis, and our Z axis are completely zeroed out, and we're in machine coordinate system here. That's all we're gonna worry about. Now we're gonna run the break-in program. In order to run the break-in program, we go down to File and Load. Click on Load. And it's going to bring up a menu where we can select whatever program we wrote or whatever we have to run on here. And ours is saved to the desktop, and it should be HX8610 Startup Program. And that's right here. And actually we've got two of them. We've got a startup program and we've got a startup program 90 inches a minute. So the 90 inches a minute runs at full speed of the machine, the capabilities of the machine. Many of our machines are requested to be turned down so the students can have a slower reactionary time. So right now we're gonna run the slower one. We're gonna run the standard run, the startup program. We're just gonna select on that and say open. And you're gonna see it's gonna fill up our screen. This is all the code that it's gonna run and any notes that's in it. The nice part about this is we don't have to set any work fixtures. This all runs from home. So once it's at home position, we can come down here, we load our program, and we hit start. And now our machine's running. And what this does is it starts off incredibly slow. I think right now we're only running about 5 inches a minute. And then it'll upgrade to 60 and then 90, I think is what it is. Or maybe it's up to 30 inches a minute on this one here, I forget. But basically, after so much time, it increments in speed. And this is so that you can start off nice and slow and have your higher torque when the machine's cold and not warmed up quite yet. And then as it starts warming up and the liquid or the lubricants become more fluid, then you can start running at higher speeds. So that's another reason why you run the break-in programs. You want everything to be up and perfectly operational when you're ready to run your machines. So we'd let this run for the next 20 minutes, and once that's done, then you're set and ready to go.
20 minutes later.
Okay, so now that the break-in program's done, we've learned how to set the gibs, how to do minor maintenance on our machines, as well as lubricating the screws in the gibs and the dovetails. And we've run our break-in program. This is something we recommend you do at least the minimum the first 6 months of ownership. The reason why is it's much like if you talk to a chef in a seasoned pan. They use cast iron pans and they talk about how you never wash them. You're just supposed to wipe them out and oil them and then you put them back, and the next time you just cook them that way. Because as soon as you wash them, it removes all of that, the oil and everything, and things start burning and sticking to it. Well, these are cast iron. They're very much the same way. When you first start running the machine and doing the break-in program, more than likely you'll start smelling a burning oil smell, and that'll happen until about I'd say the first 20 hours of solid use on this machine. After that, you shouldn't smell any more burning oil, because what'll happen is the oil will penetrate the top layers of the cast iron, and at that point you're just maintaining lubrication. So from this point on, we want to make sure we're running our break-in program daily, at least a 20-minute routine. We're doing our daily lubrication, doing the lead screws and the dovetails, as well as the gib adjustments. And we just want to make sure we're doing that so that we get better repeatability, better performance, and making sure that the wear is even across the machines during use. So let's make sure that you click like and subscribe down below. If you didn't like this, or you got questions and comments, hit the questions comments area below. Make sure you check the bell on the bottom so that you get any updates when we do any new updates, because any kind of adjustments or anything like that, we'll post a video first before we do a written manual. Most people don't read anyway, so we'll give them a video. It makes it so much easier. And we'll see you next time.